Hi everyone, welcome back. Let's take a look at problem 3. Oh no, look at all these bow ties. Where did they come from? And what do they mean? Okay, number 3. It says a parabolic curve is to be used to model a dip in the highway. The road dips for 327 meters in a horizontal distance of 120 meters and then rises to the previous height in another 120 meters. So I drew a picture here. So it dips down 32.7 meters and then it comes back up to the original height. And it takes 120 meters for it to go down and then another 120 meters to come back up. So let's see, it says write the equation of the curve on the roadway taking the origin at the bottom of the dip. So right down here would be 0, 0. And the y-axis vertical. And so our x-axis would be here. Well, this is a function. And so it's going to follow the form 4p times y minus k is equal to x minus h quantity squared. Well, if we write that down here, we know the vertex is 0, 0. So plug 0 in for h, 0 in for k. And then we need one other point to figure out what p is. Well, we know we go 120 meters to the left or to the right, but we also have to go up the 27.2 meters. So this point over here would be 120, 32.7. This point over here would be negative 120, 32.7. Well, I like the positive numbers, so plug in the positive 120, plug in the positive 32.7, do the math and solve for P, and you get 110.0917 and so on. Well, that's all good and fine, but what we really need is 4P. So multiply both sides by 4, and you get 4P is equal to 440.3669. And then when you plug it back in here, you get 440.3669y is equal to x squared. Okay, let's take a look at problem 4. Oh no, what do we have here? We have some more bow ties. Okay. Hey, it's the last video. Gotta have fun. Okay, number 4 says a parabolic arch supports a roadway as shown in the picture. So here's the arch, here's the roadway. The arch is 200 meters wide at the bottom and 104 meters tall. Find the vertical distance from the top roadway to the arch that is 46 meters from the center. Assume the top roadway is directly on top of the arch. So what it's asking here is we have this arch. If we look at this center line and we want to go 46 meters off of the center line, it wants to know how far it is to the roadway. So what is this vertical distance here? Well, we know that this is a parabola that opens down, so it passes the vertical line test, so it's a function. So we're going to use the form that has y minus k to the first power, because we could move all of these numbers and variables over to the right side, and then we would have y is equal to something, and so it would be a function. So we're going to use this form. So we could let our x and y axis be anywhere. Well, I chose to let the roadway be the x-axis and then the y-axis go right down the middle. And so our vertex would be the point 0, 0. So plug 0 in for h, 0 in for k, and then we need to find some other point. so we can figure out what P is. Well, if we go down 104 meters, that's where the arch is 200 meters wide. So 100 meters to the right, 100 meters to the left, so we would have these points. Well, I like the positive number, so let's choose this point. So if we plug 100 in for X and negative 104 in for Y, and we do the math, we get P is equal to negative 24.0384 and so on. Well, that's all good and fine, but what we really want to know is what 4P is equal to. So multiply both sides by 4, we get 4P is equal to negative 96.1538 and so on. And so we can plug this number in for 4P. So the equation would be negative 96.1538y is equal to x squared. Okay, so then it wants to know this distance. Well, we know the x value would be 46. So plug in 46 squared, divide, and you get a y value of 22.0064. Okay, so what does that mean? Well, remember our x-axis was here, and so we would go down 22.0064 meters to get to this point. So that means that this distance would be a positive 22.64 meters, because distances are always measured in meters. So here's the bow ties once again that I was going to bring into class but never did. I hope you have a wonderful summer. Stay in touch. Get back with me, and let me know what you're doing, especially when you graduate. Let me know where you're going. I'll talk to you later. Have a wonderful summer.